Hi friends, this is Muhammad Jibran and welcome to our C language tutorials. In the previous video, I had explained you how FCFS or first come first serve works, and now we are going to write an C program to implement the FCFS algorithm. If you have not seen the previous video, I would suggest you to please go back and watch the explanation of this program or this algorithm so that you can understand what we are doing over here. So let's start writing our code. First of all, we'll be requiring some variables. We'll declare one variable as n to hold all the number of processes, and we'll be requiring one more variable like exe time to hold the burst time or the execution time of each and every process. We'll make it as an array so that we can store more than one process, the burst time of more than one process. And if you need this function, you may call it. So when we are done with that, first of all, what I want to do is I want to get the number of processes from the user. So for that, I will prompt to the user that enter number of processes, and when he enters the number of processes, then I would like to store that in our variable that is n, as I have told you. And once we have total number of processes, then we can work with the for loop. We'll create one more variable as int I. We'll use I to work with on our for loop. The I should not be more than n value, and in our for loop, what we'll be doing is we'll be storing all the values of the burst times in our exe array. So for that, we can do something like this. We'll say %d and exe time. Now this will store the value in our array, but I always like to give some response to the user, like what my program wants, what my program is expecting from the user. So just for that reason, I'm giving one printf statement over here. If you don't want it, you can skip this. You can say enter the exe or execution time for process %d. What does this %d mean? %d is the location or the position of our process. So why I plus 1? Because I value is from 0, and I would like to show the processes beginning from 1. I don't want to show from 0. So for that reason, I'm writing it I plus 1. I hope you all know how to work with arrays. If you don't know that, please go and have a look on my videos on arrays. You will understand what I'm doing over there. Now first of all, let us just print our array, whatever we have done till now. The same for loop we'll be using, and within that I would like to print the burst times. I will say %d tab just to give some space, again a %d, and over here I will say I plus 1 to have the location or the position of our or the now location of the process. Again, sorry, I plus 1 I'm writing over here just to have the, oh my god, I again forgot, just to have the position of our process. Thank god, did this time. And the second time what I will be printing is the exe time, that is I. So now we will be printing all the process positions and their burst times. We'll write one more printf statement just to make it more explanatory. We'll write PID, stands for burst process ID, and we'll write BT, which stands for the burst time. And if we run our program right now, it says enter number of processes, 3 process, enter the exe time for process 1, 6, 4 and 1. make it nice. Now if we do it, number of processes 4, process 1 is 3, 8, 4 and 1. Now the process for the process ID 1, the burst time is 3. Second process has the burst time 8, third has the 4 and fourth has the 1. So now we are able to print all the burst times of each and every process. Now what I would like to do is calculate the waiting time of each and every process. So for that I'm going to use one more variable, w time, and what this w time will give is the waiting time of each and every process. So after declaring this variable, we will directly come down to our for loop. First let me write wt, which stands for waiting time, and over here we'll write again tab %d, and in here we'll be passing the value in our w time variable. So the first time the w time variable gets printed is 0, because the waiting time for the first process is 0, and the next time when the w time should gets printed, it's after the execution, the complete execution of our previous process. So for that we will write w time plus equals exe time I. Okay, so now if I run this, and we'll go with 3 processes. First process burst time is 6, 2 and 4. Now we have the waiting times also. The first process, which has the burst time or the execution time 6, has did not waited anything, and it got executed directly, as it is first come first serve. So the waiting time for first process was 0. After that the second process had to wait for 6 seconds or 6 milliseconds, as the first process took 6 seconds for complete execution. Once this first process got completely executed, we started working with the second process. Second process took again 2 seconds to completely executing. After that the third process, when it entered into the process, it was around 8 seconds when it started its execution, and its burst time will be 4 seconds. So this is how we calculated the burst time. Now we would like to calculate the turnaround time for each and every process. So for that we'll create one more variable, say t80. Again we'll assign it to 0, or if you don't want, you can remove it, and then we'll again go back to our this for loop where we have been working. So in that what we'll do is first of all we'll assign TAT to the sum of exe time and our waiting time. So what is turnaround time? If you remember, turnaround time is the sum of execution time and the waiting time. That's what we are writing over here, and here we'll write again one more tab %d, and here we'll write t80, and on the heading we will write tab, we'll say TAT for the turnaround time, and if we again execute it, I will give 3 processes with 6, 5 and 8, and now we have the turnaround times also, which is the sum of burst time and the waiting time. 6 plus 0 is 6, 5 plus 6 is 11, 8 plus 11 is 9. So now we are done with the burst times, waiting times and the turnaround times. What we are left with is just the calculating the average waiting time and the average turnaround time. So for that I would like to create some more variables. This time we'll go for float. We'll say AWT for average waiting time, and we'll say ATAT for average turnaround time, and we'll be having two more variables, underscore AWT, which I will assign to 0, and one more, that is underscore ATAT, which I will again assign to 0. Now to explain what these variables are for, what is happening over here is important. We are storing the values of waiting time and the turnaround time every time we are executing this for loop. So I want to store all the values of this W time and this TAT variable in a particular variable, so that I can find the average out of that. So for that, what we'll do is, in this for loop only, I will call the AWT variable, and I will assign it to all the waiting times. So I will be adding all the waiting times in our underscore AWT variable, and I will do the same with our ATAT variable, in which I will be adding all the turnaround times of our each and every process. So once we are done with that, we will be having all the all the waiting times, the sum of waiting times and the sum of turnaround times, so that we can find the average out of it. So we'll say AWT will be equal to underscore AWT by n. N is the number of processes, and we'll again say the same thing, will be equal to underscore ATAT by n. Now we have the average turnaround time, and we can just print them off, and this will end up our work. Here I will write average waiting time will be %d, and the value will be coming from AWT, and here I will say average turn around time, and it will be like 8080. Now if we execute this code, everything should work fine. The number of processes is 3, the 5, 9 and 2. Sorry, I always forget this thing. Now the number of processes 3, will type in the same values. Oops, we did not got the values over here. As why? Because instead of F for the floats, I have written D for the integers. So now if we try to run our application, I will again give the same values, 5, 9 and 2, and now we have the values. So it says the average turnaround time is this, and average waiting time is this. So this is how your algorithm for FCFS works. So there is a small change I would like to make. I will just cut it and I will paste it over here. Why? Because our average turnaround time value was coming wrong. The average waiting time was coming wrong, because for the first time we are not counting and we are not storing that. Now we have the correct answer. Now if we run the code for the same values again, now we have the average waiting time as 6.33 and the turnaround time as 11.667. If you see the difference over here, if I execute the same code for 3 processes, now you see we have this problem. We are having the waiting time and the turnaround time as equal, because we are not calculating the waiting time for the first process. We are like working with the values from the second time. So we don't want it, we wanted a accurate answer. So that's the reason you just need to make this small change in the code. So that's it for this tutorial. Hope you liked it, and thanks for watching.